A prime is the image of A after a dilation centered at the origin with a scale factor of 2. So what was A? Well, A was whatever xy led you to A prime, which was -10, -8. And what was the rule? Times 2. So that means that this one must have been -5, -4 in order to get this as the result. So that should be your answer. So I'm going to say that again. -5, -4 doubled is this. So that must have been the pre-image coordinates. P prime is the image after a dilation centered at the origin with a scale factor of 1/3. What are the coordinates of P? That means that P was 3 times as big as P prime, since this thing was a reduction. And I mean, P got smaller to get P prime, so P was bigger. So that's how you're going to figure out what to do. So we're going to take P prime and multiply by 3 to get -6, 15. So here's your original P. Those numbers had to have been the original P, so that 1/3 of them gets you that. 1/3 of these is that. 1/3 of those is that. All right. Identifying the scale factor. We're going to skip these two just for the sake of time. Go down 15, please. Identify the scale factor. Well, if D was the original, you need to make sure you know that that's where it started. That's where it ended up. So we need to think about if this was like the original D and it goes there, what's that, enlargement or reduction? Reduction. So we need our scale factor K to be some number like 1/2 or 1/3. Well, let's just see. Okay, 1, 2, 3, 4, 5, 6. That was the original D. Well, how did you get to D prime? Well, it looks like it ends up at 2. Sorry, this one. 0, 2. Well, how would you get that number from 6? Would you divide? Would you multiply? To get from 6 to 2? Well, the answer is that you would divide. But all of these problems are supposed to be about multiplication, so, how do we handle that? You multiply by 1/3. That's the same as dividing by 3. So that takes care of the fact that it reduced by a factor of 3. So your K value has to be a number that you could multiply this number by and get that number. And it will work on the other points because they're already telling us like it's legitimate. It's a dilation. So I don't have to check and see if it works on the other ones. All right. What's the dilation here? Origin to W gives you -2, 2. But W prime is way out here at -8, 8. Well, what happened? Multiplied or divided? It multiplied. And by how much? Well, 2 times something is 8. Well, that's 4. 2 times 4 is 8. 2 times 4 is 8. So that's the scale factor of this enlargement. Just be careful that you pay attention to where the original was. This is the original. Because it's got the capital letters without the little tick marks on them. That's how you know what that is. Okay. Let's see what's up. Dilations from other fixed points. 1 second, please. I don't think we're going to do this. It's just really, really, really hard. I don't want to put you through that. Yeah, this is not going to happen. It's by vectors. So we're not doing page 25 or page 26. But I do need you to pick up with me on 27. Identify the center of the dilation. If I trace this back, there was the original, there's the new. So where would the center have been? This went down 3/2. So down 3/2. Looks like that would have been the center. Sorry, I keep shaking. And then this one looks like it traces back exactly to there too, where this matches that. This one traces back to there too. So that looks like that's actually the center of this rotation. So we look at 1, 2, 3, 4, 5. 1, 5. Does it double in size or reduce? Well, the original is the big one, so it actually reduced by 1/2. Remember, these match, so it must have been 1/2 as big. And then you just keep going on these. Pause it. Try the 7 and 8, and we'll come back together.